Hello and welcome to this Wood Solutions presentation on wood structural properties such as strength and stiffness. All structural applications in buildings are regulated. This generates significant demand for all building materials to provide reliable structural performance. As a result, wood's structural properties are critical to how it performs and is used in buildings and similar applications. Wood has a wide range of structural properties and all influence its structural performance in a building. Two of the most important properties are timber's strength and stiffness in bending. We will discuss both here. Strength and stiffness are critical aspects of any material used in structural design. Strength is when a material breaks under load. This is its failure point. Its stiffness is how much it bends under load. For example, with a joist in a floor, it is important to know how much it bends when someone walks over it, and if it will break if too many people stand on it. The amount that it bends depends on the timber's stiffness. The load or the number of people that the joist can take before breaking depends on its strength. Timber's strength and stiffness are related to the wood's cell structure, the cell structure's size and arrangement, and their direction relative to the applied load, and finally to their moisture content. Timber's cell structures are like a group of tubes joined together. The cells are strong and stiff if load are applied along the line of the cells, parallel to and through the tubes. If the cell wall is relatively thick, the cells will be stronger parallel to the tubes than when the cell wall is relatively thin. So the character of the cells makes a difference. Also, the cells are much weaker when load is applied across the tubes perpendicular to them. The cells can pull apart or crush relatively easily when load is applied this way. The reduction in strength with the direction of the applied load is significant. If strength along the cells is set as a value of 100, then the strength across the cells can be as low as 10 or less. So it is obvious that as soon as the direction of the load moves away from running directly along the cells, the capacity of the timber to resist the load reduces. Obviously, the more the load runs across the grain, the more strength the timber loses. This can occur naturally. When the cells sweep around an obstruction in the wood, like a knot, the load applied along the piece has to be resisted across the cells near the knot. The load doesn't run parallel with the cells anymore because the cells actually sweep around the knot. This significantly reduces the strength piece. Lastly, the wood's moisture content makes a difference. When the timber cells are dry, the cells walls are harder and they can resist a higher load. The strength and stiffness of a piece of timber is then largely determined by two things: the wood's cell structure, which is a function of the timber species, and the characteristics of the individual piece. This influences its cell direction and its moisture content. The timber species will influence its strength. As species characteristics largely determine cell structure and arrangement, wood from an individual species has a broadly similar structural properties. The properties of the wood from individual species has largely been determined, then compared and grouped together with other species with similar structural performance. These are called strength groups. There are 7 strength groups for unseasoned timber, and they run from S1 to S7, with S1 being the strongest timber. There are also 8 strength groups for seasoned timber. These run from SD1 to SD8, with SD1 being the strongest timber. Strength reducing characteristics of the individual piece, such as knots and sloping grain, then influence its final strength and stiffness. So individual pieces of timber will be graded or sorted into groups that have similar levels of strength reducing characteristics. Finally, timber's moisture content is important. The structural properties of a seasoned piece of timber are about 30% above those of an unseasoned piece. In summary, strength and stiffness are critical structural aspects of any material used in design. Strength is when the material breaks under load, and stiffness is how much it bends under load. Timber's strength and stiffness is related to the wood's cell structure, their size and arrangement, and their direction relative to the applied load. Wood cells are strong and stiff if loads are applied along the cells. The cells are much weaker when load is applied across the cells.